What's up, guys? In this video, what I want to do is get you ready for polynomials in Algebra 2. And we're going to do that is kind of work through multiple different problems that you definitely need to know before you get started inside of the chapter. So let's go ahead and get yourself ready and prepared, and let's work through these examples. Now, you can also follow along through this video using the chapter section. All right, so let's go ahead and get started in the first one, which is again going to be like the nemesis of a majority of students, and that's just going to be factoring. Now, that's going to be very important when we're trying to go ahead and factor polynomials. So this is going to be factoring our quadratics. So in this case, we can have some quadratic trinomials, and I think that's what we're going to work on. Yeah, it's just a lot of quadratic trinomials. Okay, so let's go ahead and get started here. Now, in this case, what we have when we want to go ahead and factor a quadratic trinomial, the main thing I want you to kind of understand for this is that all quadratic trinomials can be broken down into a product of two binomials. All right. And if you remember, like all factoring is rewriting an expression as a product. So you can see that this is an expression with three terms separated by addition. And what we're trying to do is rewrite this expression as a product. And the way that this is going to work is, remember, when you multiply binomial times a binomial, you have to apply like FOIL, or the distributive property, right? So if I put an x and an x here, right, I know that x times x is going to give me x squared, right? Now what we want to do is say, well, what two numbers multiply to give me 30? So there's a lot, right? Well, not a lot, but I mean, as far as integers, we have 30 times 1, right? We have 15 times 2, and we have a 6 times 5, and we have a 10 times 3. Right? So these are all the values that multiply to give me 30. In addition to that, though, also we could do the negative, right? Negative 30 times negative 1 is going to be a positive 30. So what I want you to kind of understand is once you kind of have these, and a lot of times we can do this in our head, that's our main goal, right? Especially now getting into like Algebra 2 or college algebra, like that's where you want to be. But I'm just kind of working through this one kind of slowly, so we're on the same, same level or same page. So the last number is a positive 30. Now, since it's a positive 30, I know it could either be both positive or both negative. And then now what we want to do is look at my middle term. If my middle term is positive and my last term is positive, then what I want to do is say, all right, which of these factors multiply to give me 30, but also add to give me a positive 13? And hopefully you can see that these two add to give me 31. This is going to be a 17. This is a 11. This gives me a 13. So you can see that 10 and 3 are going to be your factors. So I have a plus 10. Plus 3. It doesn't really matter in this case how they're going to multiply out, because again, remember when you apply the distributive property, x times x is x squared, right? 10 times 3 is going to be the 30. And what happens here is these two terms are going to add up to give me my 10x, and then this is going to give me my 3x, which you can see again how they actually you can always work back your answer to get back the right answer. And that's one thing I just want you to be able to do. Like as you're working through problems with factoring, always remember you can multiply them back to get your solution. All right, so now let's kind of go through this example. Now, this one's very similar to the last one. The last number is a positive, but the middle term is negative. So what that tells me now is that both of my factors, rather than have to both be positive, both of my factors have to both be negative, right? Because a negative times a negative is going to add to a positive, but a negative plus a negative is still going to be a negative. So think about the numbers that multiply to give you 20, right? What two numbers multiply to give you 20, but then add to give you a 9? Well, the cool thing is 20 has less factors than 30, but you can see then that 5 times 4, right, is going to work. Now, again, remember, it has to be both. They both have to be negative, right, to get a negative 9. So I'm still going to write this out as a product of two factors, right? X and X, okay? And then now we can just say, all right, now they both have to be negative, so it doesn't matter which one is which. They're both, you can go ahead and multiply this out, and you can see it's going to simplify to give you that answer. Now, in this next example, this is where it starts to get a little bit tricky here. And the reason why this is going to get a little tricky, because now my last term is negative. So when you think about the numbers that multiply to give you negative 12, when it's a negative, that means one factor is positive and one factor is going to be negative. So again, I still want to write down everything, but I'm not going to, in this case, what I'm going to do though is I'm not going to write like all the versions. I'm just going to write down the factors, and then we'll deal with the positive and the negatives later. So I have a 12 times 1, right? I could do a 6 times 2, or I could do a 4 times 3. Now, the thing I want you to think about though is, so if this is negative, we know one of these has to be positive, one of these has to be negative. Now let's go and look at my middle term. And what the middle term is going to tell you, remember when it was positive or when it was negative, like when we had the last number was positive, basically what that says is this tells us it is a sum, right? So you can think about that as a sum. Now, when the last number is negative, what you can think about that as a difference. And what I mean by that is you're now looking at the difference between your two factors. So again, previous example, we are combining them, right? Either adding two negative numbers or adding two positive numbers because the last number was positive. In this example, when the last number is negative, we're looking at the difference of the two factors. So which of these factors have a difference of 4? Well, again, you can see that, oh, 6 and 2 have a difference of 4. So those are my factors. So again, I'm going to write this as a product of two factors, right? I know that my x's have to be in front. Now, my problem is I know it's going to be a 6 and 2, right? So 6 and 2. But which one's positive, which one's negative? Well, think about it. Is a negative 6 plus 2 negative 4, or is a positive 6 plus negative 2 4? And hopefully you can see that when 6 is negative, that's going to give me a negative 4. So I'll do an x minus 6 and x plus 2. All right. Now, in this case, again, we're doing the exact same thing. Notice, oh, this is negative, right? So that's a difference. But now my difference needs to be a positive 6. So let's write down the factors of 27. Again, forgetting about the positive and the negative. So see, we have a 27 times 1, and we have a 9 times 3. Hopefully you recognize that, like, oh, 9 and 3 have a difference, right? Not 27 and 1. So, and then again, since my difference is a positive 6, which should be negative and which should be positive? Well, you don't want the 9 to be negative, right? You're going to want the 3. So therefore, I can factor this as an x plus 9 times an x minus 3. Now, everything that we just taught gets completely thrown out the window when we now go ahead and look at a quadratic when my a is not equal to 1. We have to approach this differently. But we can approach it a little bit the same way because, it's still a quadratic trinomial. And all quadratic trinomials can still be written down as a product of two binomials. So I can still rewrite this as a 2x times an x, right? Now we want to say, well, what two numbers multiply give us 2? And thankfully, 2 and 1, or 2, what two numbers multiply give you 2 is just going to be a 2 and a 1, right? Now, it could be a negative 2 and a negative 1, but that's why we want to look at our last number. Since our middle term is positive, we know we're going to be adding them together, right? But we're not adding the 2 and the 1, because now what we're looking for, and actually this is incorrectly written. I think this is supposed to be a 2 and a 1, because that's not going to work. That's actually supposed to be a 1. So let's go ahead and fix that, right? That's supposed to be 2x plus 1. Yeah. So again, I wrote that down wrong. Sorry. So in this case, we have a 1, or that's supposed to be a 1 right there. And so otherwise it wouldn't be factorable. So now what we have is like, what two numbers multiply against 1? Well, it's 1 and 1, or negative 1 and negative 1. But since my middle term is positive, I know that's going to be a positive 1, right? So the main thing that I want you to understand, though, in this case is it obviously has to be a 1 and 1. This one's actually fairly easy. But again, the main thing you want to do is, how are you going to get this 3x? Well, again, the 3x comes again, does 2x times x give me 2x squared? Yes. Does 1 times 1 give me a positive 1? Yes. And then to find this middle term, what we're going to do is we're going to multiply my inner as well as my outer. And then we have to combine those. So that's going to be an x plus 2x. Does an x plus 2x give me a 3x? Yes, it does. Okay, so my first two terms should give me my first term of my trinomial. My last two terms should multiply to give me my last term of my trinomial. And the inner and the outer are going to multiply and then combine to give me that middle term 3x. That's how you can sometimes tell, where you should put those factors, like in which binomial. And let's see, no, we don't have another example from there, but we'll get into more practice with that. But hopefully that's just a quick little review of the factoring for there. Now in this example, I think it's really important also. A lot of times students will give up and they say, oh, there's an A in front of here, or, there's a number in front. This is too hard. Again, remember, you can always factor something out, right? All three of these can be divided by 3, right? 3 can divide into all of those. So you can rewrite this. Whatever you divide out, put it outside. Remember we're factoring, right? So we're rewriting this as a product. So I put the 3 on the outside, and that's going to be left with an x squared minus, let's see, that's going to be a 3 x plus 2. Okay, now again, we want to say, all right, we're multiply to give me 2, but we want to, what two numbers are going to add to give me negative 3? That's obviously going to be a 2 and a 1. So therefore I have a 3 times a what? Now they both need to be negative, right? And because they need to multiply to give me positive, add to give me negative. So therefore that's going to be an x minus 2 times a x minus 1. Hopefully I didn't need to explain myself over too much on this one. And you guys are like, oh, I'm maybe starting to get a little bit familiar with the factoring, because now it's time to switch to simplifying the expressions. So in this example, what we're going to do is we're just going to review all the rules of exponents. So there's a lot of rules of exponents, and it's really going to be helpful to kind of just remember them, kind of quickly, and to be able to apply them. So in this example, we have what we call the power to product rule. And basically what that says is whenever you have an expression separated by multiplication, you can distribute that power to both of those terms. Because technically what this is 4x times 4x times 4x. That's what 4x cubed represents. 4x times 4x times 4x. Okay, that's what it represents. So in this case, 4 times 4 times 4, right? It's going to be 4 times 4 is 16, and therefore that's going to be a 64. And therefore x times x times x is just going to be an x cubed. Now in this example, we have a negative 2 raised to the fourth, and then we have a negative 3 squared. Now it's really important to recognize that negative 2 to the fourth is not the same thing as a negative 2 to the fourth. Okay, this is very different. So negative 2 to the fourth means, again, a negative 2 times negative 2 times negative 2 times negative 2. This means a negative times 2 times 2 times 2 times 2, right? So just be very careful and understanding how the difference is between those two. So again, what's 2 times 2 times 2 is 8. So this is going to equal a positive 16. And then negative 3 squared is going to be a positive 9. And therefore, that's just going to equal a positive 25. Okay, so even though they're both negative, they're both being raised to a positive power. Anytime you have a negative raised to a positive power, it's always going to be a positive number. Remember, anything raised to the 0 power, anything raised to the 0 power is just going to be 1. Anything raised to a negative power can be rewritten as its reciprocal. So in this case, I can rewrite this as a 1 over a 6x, right? Raised to the first power. Now, again, there's really nothing. Raised to the 6th power just means it's like itself, right? It's not it's like multiplied of itself. Like, so therefore we can just simplify this to a 1 over a 6x. Now we have some multiplying of exponents. So the main thing here is like when you're multiplying exponents times exponents, in this example, you can basically just rewrite this as like one expression, right? 2 times x squared times y times a 4x times a y squared. And what I want you to be able to see is like we can just rearrange our terms, right? It doesn't matter if you multiply 4 times 3 or 3 times 4. Like the order doesn't matter. So in this example, what I'm going to do is I'm just going to put the numbers first. So I'll do 2 times 4, and then I'll do a times an x squared times x. And then I'll do a y times a y squared. All right, now let's just go ahead and simplify. So 2 times 4 is 8. X squared times x is an x cubed. And then y times y squared is going to be a y cubed. All right, so that's how multiplication works. For division is the same thing. Like you're just going to want to like divide your numbers and then divide your variables. Now, one thing I did forget to tell you is, or just remember when you're multiplying exponents, you add the powers, right? So technically, if you just have a variable, that's like x to the first power. So 2 plus 1 is going to be 3, right? And same thing over here. Now, when you're dividing, to simplify that with variables, you're going to subtract the powers. So in this example, what I can do is I can kind of break this up. I can break this up into a 3 over an 18 times a z cubed over a z to the 5th. All right. Now, again, we just want to simplify this. So what can we divide that's the same in the numerator and the denominator here? Well, that's just going to be a 3. So I can divide a 3 on the top and a 3 on the bottom. So what that's going to give me is a 1 over 6. And then in this case, I can rewrite a z cubed over z to the 5th. Remember, subtract the powers. So that's going to be a z to the negative 2nd power. And remember, we can rewrite a negative as a reciprocal. So therefore, I can rewrite my final answer as a 1 over a 6z, right? It's now going to go in my denominator. So that's just a good review of your rules of exponents. Now let's go and get into sketching the graph of a quadratic. So there's many different ways to sketch the graph of the quadratic, and it really kind of depends, in my opinion, of like what you're given. So if something's factorable, well, it really depends on what you need. Like if you just need to sketch a graph or if you need to identify the vertex. And in this case, it's just a sketch the graph. So I'm going to go with kind of like what I have and what I can kind of use. Because sometimes finding the vertex or finding the intercepts is going to be a little bit easier than other parts. So in this case, I have a y equals x squared minus 6x minus 7. That looks like that's factorable. So I'm going to go ahead and factor this. And so therefore, let's see, this is going to be what two numbers multiply to give you negative 7, right? But then add to give you negative 6. So I think of my or they have a difference of 6, right? Because the middle term is going to be difference. So obviously you think 7 and 1 have a difference of 6, so that's easy. And since I need to get a negative 6, then I'm going to want a negative 7. So I have an x and an x, right? I'll want a negative 7 and then a positive 1, okay? Now, that is it in factored form. And the reason why factoring is so important is because if I wanted to like sketch the graph or if I want to solve an equation, when I have a product equal to 0, I can apply what we call the zero product property. So let's see how this would kind of work. If I wanted to sketch this graph, one way we could sketch a graph is by using the intercepts. Okay. So if I want to find the x-intercepts, if you think about like on a graph, okay, the x-intercepts are going to be where the graph crosses the x-axis, and the y-intercepts is going to be where the graph crosses the y-axis. Now, the interesting thing about the x-intercepts, like if you kind of go like on the, if I want to say, where's the graph cross the x-axis? The y value, like the value of y on the x-axis is 0. So if I want to find the x-intercepts, just put y equal to 0. All right, so when I put 0 equal to, or 0 equal to y, I now have a product equal to 0. Now, the reason why this is important, so important is because that 0 product property, what that does is say, if this times this is equal to 0, then either x plus 1 equals 0 or a x minus 7 equals 0. And now I just have a linear equation that I can solve. So I can subtract 1 on both sides. So x equals a negative 1. Let's add some extra ones because it's going to be kind of big. So x equals a negative 1, or we could say x is equal to a positive 7. So 1, 2, 3, 4, 5, 6, 7. Perfect. Okay. Now, if we have any kind of like experience with graphing, like quadratics, which hopefully you kind of have at least an idea of the parabola shape and like what the graph is going to look like, you recognize that a in this case is going to be a positive 1. So therefore, the graph is going to look something like this. Actually, hold on. There's one more thing I want to do. If I just found the x-intercept, why don't we find the y-intercept? So the y-intercept in this case is going to be, the y-intercept is when x is equal to 0, right? So if we plug 0 in for x, and we get y equals a negative 7. Okay, so now I'll go 1, 2, 3, 4, 5, 6, 7. Okay, so now it has my x-intercept, x-intercept, y-intercept, x-intercept. So hopefully you understand by given this information, I can now sketch the graph, and it has to open up if I'm kind of following that parabola format. There we go, something like that. Let's just go ahead and try that again. I'll try that again. No, all right, doesn't like that. So we'll just do a really bad parabola, and it'll look something like that, which is not pretty, but hopefully you get the idea. It wouldn't work facing down. Now let's go and do a problem like this. Now this problem, or this quadratic, might look a little different. Again, the function notation does not really change anything. That's just a different way to represent a quadratic. In this case, we can call it a name like Frank or Felicia. That's really the f of x is just representing a function, which a quadratic is. Now, in this one, I'm going to show you a different approach. For this one, what we're going to do is kind of like the table method. And this is something we spend a lot of time with in like Algebra 1. But again, this is important if you need to find like the vertex or the axis of symmetry from on there. And again, we're just going to try to sketch the graph. That's it. So the main thing you want to do in this case is be able to find the axis of symmetry. Okay, so the axis of symmetry is going to be a opposite of b divided by 2 times a. Okay, so again, this is going off of the standard form of the quadratic, which is ax squared plus a bx plus c. So in this case, we say opposite of b. So b in this case is negative 4. It's going to be a positive 4 divided by a 2 times 1/2. And again, like we could do the factoring technique as well. But again, sometimes you're going to have quadratics that are not factorable. So that's why that's not going to be a case. And then also sometimes you're going to have quadratics that sometimes you're also going to have quadratics that you don't want to factor or you struggle. Like this one could be difficult or it could be non-factorable, right? So let's just do it this other technique. And you can see actually this isn't bad. The x-axis is actually 2 times 1/2 is 1 divided by 4. So that's going to be a 4, right? So the axis of symmetry is actually when x equals, okay? So therefore that equals x equals 4. Cool. So the graph is going to look something like this. All right, so let's go to 1, 2, 3, 4, and we're just going to do a nice little dash line. Okay, now what we want to do is be able to identify the vertex. So to identify the vertex, what you're simply going to do is take the axis symmetry, in this case is 4, and you're just going to find the y value of that, or the output value. So what you do is you're going to say f of 4, okay, and now you're just going to plug a 4 from there. So I have a 1/2 times a 4. Don't want to do that squared there. So we'll do a 4 quantity squared minus a 4 times 4 minus 4. Okay, so in this case, now let's follow the order of operations. We're going to square first. 4 squared is going to be 16, times 1/2 is going to be an 8. Negative 4 times 4 is going to be a negative 16, and then minus 4. Okay, so negative 16 minus 4 is a negative 20. So let's see, we have an 8 minus a 20. So you have $8, you owe me $20, so now you owe me $12. All right, so my x value is going to be a 4, and my y value is a negative 12. All right, so we went over 4, let's go down 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that value is going to be right there. Now, how would you find like other points on the graph, right? What if you didn't know the graph opened up or opened down? So what I would recommend doing is pick a point to the left as well as to the right of the vertex, right? Because when we're creating like a table of values, typically what I always recommend my students is like, just all you got to do, like pick some values either to the left or to the right. And the reason why is because this axis is symmetry. It's symmetry. It means whatever's on the left-hand side is going to be, you can reflect that about that line of symmetry, and you're going to get that on the right-hand side. So let's do one more value, but let's do a value that's going to like kind of make sense. how about we plug the value in 2, right? So again, if I was like creating a table, right, it could do like an XY table, right? And this is a lot of times like we spend time when we're first learning the graph. So we already plugged in 4, right? And we got negative 12. Now the key thing is I want to think of a number that I don't want to pick any number, right? I don't want to pick a 3 because if you pick 3 that you're going to square it, that's 9. 9 times 1/2 is going to be a fraction. I don't want to deal with fractions. So I want to think of a number that I can square that when I multiply it by 1/2, it's going to give me a number. And the number that's coming to mind in my case is going to be a 2, which seems relatively easy. So what if I did f of 2, right? Well, that'd be a 1/2 times a 2 squared minus a 4 times 2 minus 4, right? So let's see, 2 squared is going to be 4. So therefore it's a 1/2 times 4 minus 8 minus 4. So 1/2 times 4 is going to be a 2 minus 8 minus 4. So let's see, negative 6, that looks like that's going to be a negative 10. So I go over 2, that's going to be down 10, which seems like it's right there. And then again, like that was 2 away from the line of symmetry. So then over here, I'm going to go 2 away from the line of symmetry, and I'm going to graph the same point. So hopefully you recognize then, oh, this graph has to open up then, right? Like hopefully you know that like when A is positive, it opens up. But if you forgot, you can see just by plugging in another point, you can see that this graph is actually wider, but it's still also opening up. This next example is, and also you can see these X and Y intercepts, which I think you would have to be either factor or use a solving technique like quadratic formula to be able to solve, which we'll get onto next. But in this last example, another one is, this one looks factorable to me. So I just want to kind of see what we have here. So in this case, we have y equals x squared plus 6x plus 9. So we're saying, all right, what two numbers multiply to give you 9, then add to give me 6. Hopefully now you're kind of like, oh, I'm kind of getting this. This is going to be an x plus 3 times an x plus 3. Now this one can sometimes get confusing for students though, because if you think about this, like how can you have the same x-intercept, right? So again, you set it equal to 0, right? X plus 3 times an x plus 3. And then you set them both equal to 0 and you get x equals, I guess I'll just rewrite it out, right? So I get an x plus 3. Why did I write that? X plus 3 equals 0 and an x plus 3 equals 0. Therefore, x equals negative 3 and x equals a negative 3. So what does this mean? Well, actually in Algebra 2, we'll kind of talk more about what this means. But for right now, you're like, well, how this is going to look? Well, there's only one of them, right? So what happens though is like it's happening twice. So x equals negative 3 is the solution twice, basically, right? And then also you can also pick points to the left and to the right if you want to. But what I want to do is I want to kind of rewrite this. Rather than writing x plus 3 times x plus 3, you can also rewrite this as an x plus 3 quantity squared. So y is equal to an x plus 3 quantity squared. That is actually going to be a preferred method of writing an equation like this. So you can see x plus 3 quantity squared has an x-intercept 3 units to the left. And that's going to be really important. That's going to come up a lot. So it's really, really, really important that you pay attention or that you see that we got the x-intercept was negative 3, right? But the equation looks like x plus 3. Very, very important. Now let's go and find some other points. Let's say you don't know if it opens up to the right or to the left. Again, let's like pick a number, right? What about we pick 0? 0 is pretty easy. So if you plugged in like, y sub 0 equals a 0 plus 3 quantity squared. Well, 0 plus 3 is 3. Plus 3 squared is going to be 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And again, like using like that table mentality, that was 3 units away from the vertex. So 3 units to the left, 1, 2, 3. I can also do a 9 here, right? And that's going to be the exact same here. And you can see how that would be kind of work. So now you can see that the graph is going to be opening up. All right. Now let's go and get into the solving using the quadratic formula. I think one of the like most important things that you could probably remember because, up to this point, it's going to just be expected that you know how to use the quadratic formula. So if you forgot the quadratic formula, let's write it out. X equals opposite of b plus or minus the square root of b squared minus 4 times a times c all over a 2 times a. Now, again, remember a couple things that are important about the quadratic formula is it has a square root, right? And you can only take the square root of positive numbers. And so a lot of times we can simplify this is, by just finding what we call like the discriminant. So we'll be talking about that a little more. I don't know why I'm getting ahead of myself. Let's just focus on doing the quadratic formula. Again, this is all going back to the ax squared plus bx plus c, right? So a lot of times when I'm doing the quadratic formula, what I like to do is just label my a, b, and c and then plug them in to simplify, all right? So remember, if there's nothing in front of your x, you can rewrite that as like a 1. So I can say a equals 1, b equals a negative 12, and c is going to equal a 30. Okay, so now I have my A, B, and my C. Now what I'm simply going to do is go ahead and, so now I have my A, B, and my C. Now I'm just going to go and plug them in. So I have x equals opposite of B, so that's going to be a positive 12, plus or minus the square root of a 12 squared minus 4 times 1 times C, which in this case is going to be a 30. That's going to be all divided by a 2 times 1. All right, so let's go ahead and simplify this. So I have 12 squared, which is 144. Negative 4 times 30 times 1 times 30 is going to be a negative 120. And that's all divided by 2. All right, so I'm just going to kind of go left to right, left to right. It's not really the best mathematically, but hopefully you're okay with me as we're trying to fit everything in space. So I have 12 plus or minus the square root. What is 144 minus 120? Well, that's going to be a 24. Divided by 2. Now we need to go ahead and back and remember like simplifying radicals. So we can simplify this radical. If you remember, like try to find the square number that divides into that. So do I have enough room over here? Yeah, I do. I'll do a little sidebar. So remember, we can rewrite 24 as, let's see, I can rewrite that as you could do an 8 times 3, but that's not going to be simplified. What about a 6 times 4? So if you did the largest square number, you always want to find a square number that divides evenly into that. So 4 evenly divides on 24. So it's going to be a 4 times 6. Well, the square root of 4 is going to be a 2 times the square root of 6, right? So therefore I can rewrite this as a 12 plus or minus a 2. Let me actually fix that up. So that's going to be a 2 times square root of 6 all over 2. Now I can take this 2 and divide it into both of these terms, and that's going to leave me with a 6 plus or minus a square root of 6. And that's going to be your answer. That's what x equals to. A lot of students will kind of forget this, like, because I kind of went all in this way. X is equal to 6 plus or minus the square root of 6. That's actually the x-intercepts. If you were to graph this, that's actually would be the two x-intercepts. So it's kind of interesting to have that for you. Now in this example, we have an a. A is not equal to 1. So yeah, you could try to like factor this, right? Or you might be like, I'm not, let's just go ahead and solve this using quadratic formula. Now the main important thing, which I didn't explain in this one, is you always want to have whenever you're doing the ax squared plus bx plus c, you just have to make sure it's equal to 0. So it doesn't matter if it's 0 equals or that is equal to 0, you just need your quadratic equal to 0. Therefore, then you can properly identify your a, b, and c. So in this case, my a is a negative 1, my b is equal to a 20, and my c is equal to a negative 25. Okay, so again, let's just go ahead and plug it in. So x equals opposite of b, so we have a negative 20 plus or minus the square root of, let's say, a b squared, so that's going to be a 20 squared. So I'm going to use parentheses. I didn't use parentheses over there. I should have. So 20 squared minus a 4 times a, which is again another 4, and then times c, which is a negative 25. And that's going to be all over, make sure you put that a over everything, over a 2 times negative 4. All right, so we got a lot going on here. So what do we have here? So we have negative 20, and then we have plus or minus. Now 20 times 20 is going to be 400, right? 2 times 2 is 4, so 20 times 20 is going to be a 400. Negative 4 times 25, that's going to be a 400. Okay, now a 4 times 25 is 100, and then times 4 is also going to be 400. And a negative times a negative times a negative is going to be a negative 400. Ooh, that's going to give me a 0. And that's all divided by 2 times 4 is a negative 8. Cool, so now what that's going to leave me with is a negative 20 plus the square root of 0 over a negative 8. Sorry for my penmanship. And obviously, what is the square root of 0? It's just 0, right? So this is going to leave me with a negative over negative, which is going to be so this is negative 20 over negative 8. Negative divided by negative is going to go to positive. On the top and bottom, what's the largest number that divides into the top and the bottom? I think that's a 4. Right? So when I do that, this is going to give me a negative 5 over a negative 2. Sorry, why did I do that? That's supposed to be a positive, right? Not because because remember the negatives are going to divide out, right? So therefore that's going to be a 5/2. So therefore we can say x is equal to a 5/2, right? And that's going to be like that third example we had in the solving quadratics up here, where there's only one x-intercept, right? So notice when my discriminant is equal to 0, I'm going to have only one x-intercept. Kind of interesting. All right, and this example, notice how it's not equal to 0. So do not say a is 2, b is 8, c is -8. No. First thing you absolutely have to do is get them all over to the same side. So -8x. So we have a 2x squared minus an 8x, right? Equals a -8. And then add the 8 to the other side. So we have a 2x squared minus 8x plus 8 is equal to 0. Now you can identify your a, b, and c. So you can say a equals 2, b equals a -8, and c equals a +8. All right, and from there, now what you can do is just plug them into the quadratic formula. So x equals the opposite of b, which is 8, plus or minus square root of b squared. So that's a -8 quantity. So quantity -8 squared minus a 4 times a, which is 2, times c, which is 8. Right, and that's all divided by 2 times a, or 2 times 2. So we have an 8 plus or minus -8 squared, which is going to be a 64. And then -2 times 4 is going to be an 8. Oh, I did 2 64s. Oh, I didn't mean to do that. Oh, I did this way. So anyways, we're going to have a 64 and 64. That's going to be all divided by 4. 8 plus or minus a 64 minus 64 is going to be 0. So that's an 8 divided by 4, which is just going to equal a 2. So there you go, ladies and gentlemen. Hopefully this video was helpful. And if it was, then you're absolutely going to love the next video I have for you here.